Hey, it's Jacob. We're looking at question 49 from the math section of ACT A10. It's a law of cosines question. If you've worked with law of cosines before, you're probably not watching this video. If you haven't worked with law of cosines before, never fear. Every law of cosines question on the ACT is exactly the same. You know you're working with law of cosines for two reasons. One, they give you law of cosines. So this here is law of cosines. That's what that equation is. The other is that you see all of the answer choices written in kind of really weird forms, right? They're not actually values, they're expressions, which initially is a little bit scary, but is actually pretty easy because you know this ends up just being a matter of rearranging than actually really solving a problem. Okay, so it ends up being basically an Algebra 1 problem with just one added little twist, and that's understanding inverse functions. Okay, so I want to attack that first because the rest of this problem is really, really easy. The law of cosine stuff is super simple. So I want to look at inverse functions really quickly. If I have a function, let's call it just f of x, if I take the inverse of that function, it cancels out with that function, right? So those cancel out and just leave behind x. And that works regardless of the order, right? F inverse of f gives me x. F of f inverse also gives me x. Okay, so they work in both directions. All right, so let's say, for example, and we're going to end up with this situation in this problem. Let's say I have the situation where I've got cosine theta is equal to a half, and I want to know what theta is. One way you could do that is just logic, right? Cosine of what angle is 1/2? If you know your unit circle, you know that that's pi over 3 or 60 degrees. But what if I say cosine theta is equal to like 0.719? And then you have no idea, right? So just an arbitrary example here. I could isolate for this theta. I can't do anything other than take the inverse cosine, right? If I take inverse cosine of cosine, it cancels out with cosine. Now I'd have to do cosine inverse of the left-hand side. I'm not canceling out, I'm just rewriting. I'd do, or the right-hand side, cosine inverse of 1/2, and that would be theta, right? Theta there is cosine inverse 1/2. I could even come over to the calculator, I could do second cosine inverse of a half, and it'll give me a value, right? That there is pi over 3. It's in radians mode. Okay, so if I have an angle within a trigonometric function, I can get the angle isolated by inverting that trig function. Okay, it's really important that when we see cosine to the -1, we recognize that that is not 1 over cosine. Okay, 1 over cosine is secant, but this notation of to the -1 means inverse. It's not like, for example, x to the -1 equaling 1 over x. Okay, that's true. That's not an inverse. That's just the exponent. This is not an exponent. This means inverse. Okay, because that's confusing, a lot of textbooks will refrain from writing cosine to the -1. Instead, they'll write arc cosine, arc sine, arc tangent, arc secant, whatever. Okay, so those are the same. For whatever reason, ACT goes with cosine to the -1, right? Inverse cosine. But if you ever happen to see arc cosine, it means the exact same thing. It's inverse cosine. Okay, again, the usefulness is that cosine inverse cancels out with cosine. Right, so that's like 95% of this problem. If you're good with that, you're good with everything. The other 5% is this largest angle issue. All right, so if you look at this triangle, you see 38, 39, 37. This is drawn to scale, but that doesn't help us, right? We can't, by inspection, figure out which of those angles is the largest. For many of you, it probably is obvious which of those angles should be the largest, but if it's not, let's take that kind of unfamiliar situation and bring it into the realm of familiarity with something that we know, right? So let's just take a right triangle, right? You've seen plenty of right triangles before. That looks more like a skateboarding ramp, but let's just say that's a triangle. It's really obvious which of these three angles is the largest in this triangle, right? It's this angle here. Okay, and if we were asked to figure out that angle being the largest, with respect to the side lengths, and that's what we have here, right? We have the side lengths, and we want to know what's the largest angle. Well, hey, that's opposite the largest side length, right? It's really obvious that this side length is opposite the largest angle. And that makes sense, right? If we're drawing a large angle, then the length of the leg, or the length of the line segment across from it, is going to be longer as that angle gets larger, right? If this angle gets larger, and now I have this part down here, this new line is going to be even longer. So the bigger the angle, the longer the line, and vice versa, right? The longer the line opposite, the larger the angle. What does that mean? That means that this is our largest angle, all right? The rest is just plugging into the formula that they've given to us. If we haven't seen that formula before, easier, right? Because we're just plugging in. We don't even have to understand. We just plug in the numbers. They tell us that the lowercase letters represent side lengths. The uppercase letters represent angles. Now, the only angle in this formula is capital C, and because we're trying to solve for this angle, this better be capital C, right? We're going to call that capital C. And then we just solve, right? So what would side length C be? Well, this would be side length C because it says opposite, right? That means away from, so the opposite side. I'm going to call this A, and I'm going to call this B. Okay, now which of these I call A and B doesn't matter. We can appreciate that for a couple of reasons. First off, if I look in the formula, A and B are first summed and then multiplied. Both of those operations are commutative, right? If I have A plus B, it's the same as B plus A. If I have A times B, it's the same as B times A. So it doesn't matter in this situation. Of course, if I flip a triangle around, right, horizontally, if I just reverse it, right, it's not going to change what angles are present there. Okay, so choosing A and B here doesn't matter. Sometimes that's really scary for students. They go, oh, what if I make one the other? Well, look and see if it matters, right? You know things back from Algebra 1, apply them. So then we just plug in, right? So C squared is going to be 39 squared. By the way, if you're good at this point, stop the video, right? There's no point in watching me solve the algebra here. All right, so 39 squared, that's equal to 38 squared plus 37 squared. Those are A and B, minus 2, 37, 38, and then cosine C. Now, it may even be helpful for you to just leave these as A, B, and C, not plugging in the numbers. Isolate for cosine of C. Once we, of course, isolate for cosine C, we're going to solve for C by taking cosine inverse. But if you leave everything as A, B, and C, it's a little bit easier to manage, so you don't have to keep writing 38, 39, 37. And over the course of 60 problems, any time you can save is going to be pretty tremendous help for you. Anyways, I've already written it out, so I'm going to continue that. If I isolate, right, I'm going to get 39 squared. I'm going to bring these over, so minus 38 squared minus 37 squared is equal to, again, minus 2 times 37, 38, cosine C. And again, I'm trying to isolate for cosine C. Why? Because I'm trying to find that angle. Right? I'm trying to find the angle, so I want to isolate for that angle. So divide each side by minus 2, 37, 38. So I'll divide both sides by that, minus 2, 37, 38. That's going to cancel with this minus 2, 37, 38, of course. That's equal to cosine C. So if I've got cosine C is equal to some value, I can solve for C by taking cosine inverse of both sides. So I'll take cosine inverse of my left-hand side here. And when I take cosine inverse of the right-hand side, right, cosine inverse of that, it's just going to cancel out cosine, right, and leave me behind C. So this here is angle C. So that's my answer. Definitely not C, D, or E, right? Those don't match at all. If I'm looking at A and B, I gotta look for the signs, right? I gotta be really careful for the negatives. I've got 39 squared minus 38 squared minus 37 squared. I've got that here. And then I'm dividing, it's not negative, but they just brought that negative out to the front, right? They took this negative and brought it up for the whole value. That's totally okay, right? If I have 7 over negative 8, that's negative 7 over 8, right? I could bring that negative out to the front and it's the same value. So that's what they've done in choice B here, and that indeed is the answer. Okay, so law of cosines questions, they're all put together very similarly. They all have answers that are left written out. You'll notice I hardly even touched the calculator here in actually solving the problem. It wasn't helpful because they left everything written out in terms of the expression. So really, really simple. This is honestly, if you ask like a fourth grader to do this, they probably could do it because they don't understand any of the complexity of law of cosines. They just say, okay, I'll plug it in. They could at least isolate for cosine C with some basic Algebra 1 knowledge. One very last thing on the topic of this law of cosines expression here, it shouldn't be too unfamiliar to you because of course you know Pythagorean theorem, right? Pythagorean theorem in a right triangle, c squared plus a squared, c squared equals a squared plus b squared. And I actually kind of see Pythagorean theorem buried in our law of cosines there. And that's because if I have, and I'll just draw it over here, I got a little space. If I do have a right triangle, try to draw a straight line this time. If I have a right triangle, notice that side C is opposite a 90-degree angle. Okay? So if C here is opposite a 90-degree angle, this C, right, capital C, is 90 degrees. And cosine of 90 degrees, right? Let's say you don't know that. It's 0. Let's say you don't know that. It's okay. Come to your calculator. Cosine of, I'm going to plug in 90. Something's going to go wrong here. I told you it's 0, but it won't be. Negative 0.44. Make sure when you're using degrees that your calculator is in degree mode. So go to mode here. You can scroll down to radian and degree. Go ahead and select degree there. And now if I go and enter that same thing again, cosine of 90, hey, that's 0. Okay? So cosine of 90, when I'm dealing with a right triangle, this whole term goes to 0, and we just leave behind Pythagorean theorem. Okay, so this is, law of cosines is basically just Pythagorean theorem generalized to cover all triangles. All right. If you got any questions, let me know. Hopefully you learned something. Hopefully you feel good about these questions. You're definitely going to see one on your ACT, so you better be prepared for it. You may not see law of cosines. You'll definitely see either law of cosines or law of sines. Again, they're all asked the same way. They'll give you the formula. They'll tell you what to do with it. They'll tell you what the variables represent. Just plug it in and you're good.